Let's take a look at how to use Desmos, which is an online graphing calculator, and we're going to use it to make graphs for science classes. And it's simply desmos.com, and you click on the graphing calculator. Now, why use Desmos? First of all, it's completely online, so you can use it anywhere. It's fairly easy to use. In fact, I think once you get used to a few of the subtle things about it, it's actually even easier to use than for Excel or Google Sheets. So, all good reasons to consider using it. So when you get to Desmos, you're going to see a graph, just like you'd expect, and we need to put some data in. So what we do is, see how there's a box over here on the left. And we're in box 1, and that's fine. So we're going to add a table. And notice it puts the X1 and Y1 in for us automatically. So what I'm going to do is put some data in. And I don't want the data to be totally linear. Now between points, I'm just hitting the tab. In fact, up here, I think I'd like another 0. We'll be consistent with our significant figures. I want it to wiggle a little bit. 4.25, 5, 4.85. And I think 5 data points is enough for right now. For graphs in science, we need to put in the labels for the axis. We need to tell the user or the reader what's going on. So all we do is we click on the wrench up there in the upper right corner. Now a few things. Let's put the labels in. I wouldn't change the grid or anything like that. So let's call the x-axis time in seconds and the y-axis displacement meters. So this is more for physics or physical science, but you certainly could use it in another class. Now, it shows all 4 quadrants here. We probably don't need to see all 4 quadrants. So let's go from maybe -1 on the x-axis. See, that gives us a little space. And let's try -1 on the y. And you can play around with these and get them to the way you'd like and the way you think would look best for you. So this is a really, really quick way. I mean, you saw we made our graph in, probably just a minute or so, not even. And when we're done with that, we'll just click on the wrench again. And don't worry, you can always click on the wrench and bring it back. Like I'm looking at the x-axis. See, we're going all the way out to 9, and our last data point's around 5. So maybe we'll just go out to 6 to make it a little bit bigger. Let me see if I like that. Yeah, not too bad. See, it's a little bigger. Now it would be nice to put the line of best fit, because especially in science, when you take data, you don't always get the perfect straight line. Usually there's some errors. So let's move off of 1 and click on 2. So what we do is we click on box 2, and we have to say Y1 because they call it Y1. And here's the little subtle thing to watch out for. Instead of hitting equals, now you may know the line of a straight line is y equals mx plus b. We're going to use a squiggle. It's called the tilde sign. So it's shift, and it's right to the left of the 1. It means approximately. And says y1 is approximately equal to m, which is our slope, x1 plus b. So you can see in red, it put the line in. And what I think is interesting then is down below, it gives us our slope. It gives us our m, 0.999. It's really close to 1. That's how I did the data. And it gives us, see where it says statistics there? The r squared value is the one that we're interested in. So that's 0.9931. So what that tells us is this data is approximately 99.3% linear. So that's really good. That means, yeah, this is a straight line. Anything above 90%, generally we say is really, really good. So what would we do with this? What I would do is I would take a screenshot. You could put it in a paint program and maybe trim it. And usually we want to add a title too. And then just paste it right in a report or print it out and include it in your report. Now let's see another thing that we might want to do. So I'm going to clear out all this data. I think I just hit the, if I just hit the X, this should clear everything out. And we can change the titles in a minute. So what I'm going to do is I have some data. I just have it in Google Sheets. Because sometimes you'll have it in another tab, or Excel. So all we have to do is highlight it, right-click, copy it, and go over to Desmos. Now click on one. I'm just going to hit Control-V, which is paste. So I can even bring in with Desmos data from another program, like I said, from Google Sheets or Excel, or there's one that we use in physics called Logger Lite. Now this data is not a straight line. Well, let's keep the axis as displacement and time. I think that's just fine. But let's go in here and change the settings, because it looks like the y goes up to 50 and the x goes up to 7. I don't think we need to have quite so much white space on the graph. So maybe we'll only have our y-axis go up to 60. I don't think it needs to start at negative 25. I think let's try negative 2. Well, that looks pretty good, I think. I can still see the label. And same thing for the x. Maybe I'll try negative 1 or negative 2. And you can play around and get, now that negative 2 isn't necessary. I think negative 1 is just fine. We don't really need to go up to 10, so maybe we'll go up to 8. And if I wanted to or I needed to, I could change these labels. But I don't need to. We'll just keep it the same for now. Now that's a curve. So you might say, well, how do I fit a curve? Here's what we do. We click on 2. Remember, it calls it y1. And we're going to use not equals, but that squiggle, the tilde. Again, it's right to the left of the 1. So I go Shift, squiggle, mx1. I want to try to do a straight line. Something that's curved is often to the second power. Now, sometimes it can be to the third. There are other powers we can use. So how do we get that? If you hold Shift and 6, you'll see it's called the caret sign. It's like a little up arrow or a little upside down V. So Shift 6 squared, hit 2. Then hit space plus B. And it's so smart it knows, as soon as I hit the space to go back down. Now we've got a curve here. You say, well, what's the equation? We know the m is 1.011185. So we could write, if we wanted to write the equation, there it is. And we know the b, which is the y-intercept, negative 0.1862. And we know that r squared value is 0.999. So that means this curve is 99% good, or the equation agrees with our points 99.9% of the time, which is very good for science. So that's a way to use Desmos to make both a linear graph and one with a curve. And thanks for watching.